Guys, please confirm to me. All of you are getting my voice on the screen. Those are attending in online. Guys, please confirm to me. All of you are getting my voice on the screen. Those are attending in online. Guys, please confirm to me. All of you are getting my voice on the screen. Guys, can you tell me what we completed there in the last session? Yeah, good morning. Good morning to you guys. Good morning to you all. What we completed there in the last class? What topic here we completed in the last session? Right, sir. Now, exception handling, that part we completed here. Now we are going to understand another new topic. Another new topic here we have to understand. Right, sir. Another new topic is like what there? Multi-threading. Another new topic is what there? Multi-threading. So overall, this multi-threading we are going to complete by this Sunday. Monday onwards, we are going to start another new topic. That and I'll give information to you what we are going to start. Right, sir. Now, I'll discuss with you clearly what exactly the meaning of multi-threading. For what purpose here we are getting this multi-threading? Right, sir. Now, guys, now just I'm going to ask one question to you before starting multi-threading. First of all, tell me answer for this question, guys. Just I'm asking one question to you. I'm going to start this multi-threading with this particular question. Answer for it. What is the difference between process, procedure, and a processor? Guys, just I'm giving 2 minutes of time to you. Now try to answer for it. As per your awareness, I'm asking to you. Come on, guys. Now everybody. You're right. Points are the same. No. process is a, or else maybe procedure is a set of instructions to represent a particular task. Procedure is a set of instructions to represent a particular task. Process is a flow of execution to perform a particular action. Process is a flow of execution to perform a particular action. Okay. Procedure already completed. Processor is a hardware component to generate processes. So these are the mainly the differences here we can identify. What is procedure, what is process, or what is a particular processor. Particular task. Say for example, I want to take a program. This program contains a set of instructions, guys. Just 1 minute. Right, so now this is like what their process where a set of instructions we are having. These are the set of instructions. Now the set of instructions is called as what their procedure. Lines of code is nothing but what their procedure. Next one is I want to execute this procedure by using a flow of execution. We are going to execute this procedure by using a flow of execution. This flow of execution is called as what their process. How this process will be generated here now? Process will be generated by a hardware component. This hardware component will generate the process as per the requirement. This is generated by a hardware component. This hardware component is called as what their processor. That's it. This is exactly the meaning of like what their process, procedure, and a processor. These differences are required if you want to start multi-threading. Definitely. Right, sir. After completion of this, everybody understand it clearly. At the beginning stages of the computers, at the beginning stage of the computer science, there are two process mechanisms to execute the applications. At the starting point of the computer science, there are two process mechanisms to execute the applications. What are the two process mechanisms to execute our applications there? First one is single process mechanism or single tasking. Second one is multi-process mechanism. Or multitasking. Multitasking. Single process mechanism or single tasking, multi-process mechanism or multitasking. Two things are available. Now just we are going to elaborate both of them. Try to understand it clearly. What is this single process mechanism? What is the meaning of the single process mechanism? Or single tasking? This mechanism is able to allow single process to execute the complete application. This mechanism is able to allow a single process to execute the complete application. Let's see this one. I will show this point scheme. For example, I have an application. This is my application. Inside my application, 3 tasks are available. Task 1, task 2, task 3. T1 task, T2 task, T3 task. Overall, 3 tasks are available. Okay. Now the point is what? To complete this T1 task, 10 units of memory, 10 units of time. To complete T2 task, again 10 units of memory, 10 units of time. To complete T3 task, 10 units of memory, 10 units of time. Like here we are getting it. Okay. Right. Now the point is what? I want to execute this total application. Now here we are going to have main memory. This is my main memory. This is like what there, main memory. The size of this main memory is what there, 100 units of memory is assigned here. Right. Now I want to execute this program. In the case of single process mechanism, what is going to be happen? First task will be loaded to the memory, main memory. First task has to be loaded to the memory. Now this is loaded. Now what happened there? When it is loaded, only one process will be assigned to execute this one. Now this process will be executed. Alright, so now if you observe this, execution time is like what there? Total execution time. Execution time as of now 10 units of time is completed. When this task is executed completely, then it will be removed. Then it will be removed. After that, next task will be loaded. Task T2 will be loaded. This is removed. Again, 100 units of memory is available. Next task will be loaded. When next task is loaded here, again 10 units of memory will be utilized here. Same process, whatever the process that we assigned to execute the first task, same process will come here. That process will complete its execution part. Okay. Now this process will be executed. Now how much is an execution time here after this? Already 10 units of time is complete. Now this task is going to be executed. As per this, how much here we are getting there? Plus 10 units of time. This also be completed. When it is completed now. When it is completed, this is going to be removed. Then again 100 units of memories come back. The next one is after this. After this, task 3 will be loaded to the memory. Task 3 will be loaded to the memory. The same process, whatever the process that we assign to execute our application, same process will be assigned to execute this particular one. This will be executed. Okay. This will be executed. Now again, then when it is executed here, it will take the same time. How much is that execution time will complete here to complete this process now? Now it will be like what there? 10 units of time again. Right, plus 10 units of time. As I'm asking one question to you, now try to answer for it. Overall, what is the total execution time now? To complete this application, what is the total execution time? Please respond to me, all of you know. 30 units of time is the total execution time here. 30 units of time. Similarly, I'm asking one question to you. What should be the total memory consumption at a time? How much memory is consumed here in this mechanism? In this overall, how much memory is consumed here? Consumed memory. Consumed memory is what there at a time. At any point of time, if we take no, max 10 units of memory only, not 30 units of memory. Max 10 units of memory will be consumed. Okay. Why? Because at a time it is executing only one task, not multiple tasks. At a time it is executing how many tasks there? Only one task, not multiple tasks. Right. That's why it is taking what there? The total memory consumption is what there? Right. 10 units of memory. Now all of you observe carefully. It is following what type of execution, guys? It follows what type of execution actually? This mechanism is able to allow a single process to execute the complete application. It follows what type of execution? Please understand it now. Sequential execution. Sequential execution for the tasks. One task, after that another task. One task, after that one task, another task. Sequential execution. Now tell me, when it follows sequential execution, tell me, all of you know, tell me, execution time will be increased or reduced? Execution time will be increased or reduced? It will increase application execution time. When application execution time is increased, what is the performance of the application? Performance will be increased or reduced? When execution time is increased, performance of the application will be increased or reduced? Definitely reduced, slow. Right, sir. Now it will reduce the application performance. It will reduce the application performance. It will reduce the application performance. That's it. These are the various points here we are getting inside, like what there? Single process mechanism. In single process mechanism, these are exactly the points here we have to understand. Everybody must follow this sequence. No? Why? Because throughout multi-threading, we are going to understand these points only. Okay. This mechanism is able to allow a single process to execute the complete application. It follows sequential execution. Next one is what there? It will increase application execution time. It will reduce the application performance. Right. Then after that, the related diagram here are given. Whatever the multitasking or multi-process mechanism. What is this multi-process mechanism? Observe carefully. Multi-process mechanism allows how many processes? No. Observe carefully. It allows more than one process to execute the complete application. How it's then how these processes are going to execute their tasks actually? I'll take one more diagram. Try to understand it. Now here we're having an application. Now inside this application, we are having some tasks. What tasks are available here? Multiple tasks, 3 tasks. As it is, I want to take 3 tasks. Okay. This is what the T1 task. This is like what the T2 task. This is like what the T3 task. As usual, to complete T1 task, how much memory it will be provided here? 10 units of memory, 10 units of time. Right, sir. Then one more point I can add there inside the single process mechanism. It will not utilize the system memory effectively. It will not utilize the system memory effectively. Actual assignment is what? There nearly 100 units of memory. Out of these 100 units of memory, just how much memory here we have used there? Only 10 units of memory we have used. Remaining 19 units of memory is a wastage. Okay? 1 minute, guys. Right, sir. System memory is not utilizing effectively. Now observe carefully inside this diagram. I want to have main memory. This is main memory. For example, here total memory is 100 units of memory. Okay. Now inside this, what's the point here I'm telling to you? In a multi-process mechanism, all three tasks we are going to load. In the case of this multi-process mechanism, all three tasks here we are going to load. Now this is like what the task 1. This is like what the task T2. This is like what the task T3. Okay. For each and every task, a separate process will be created. Now this I am telling that this process here I am telling to you. Now this is what I am telling you, process P1. Next one is apart from this. For a task T2, process P2 will be created. This I am telling to you, P2 process. Next one is for a task T3, another process will be created. P3 process. Okay. Right. P1 process, P2 process. Then what next one here? No, P3 process. Then what happened here? To control all the processes and to manage all the processes, here we are going to use a separate queue. Here we are going to use what? The queue, separate queue here we are going to use. This queue is called process waiting queue. This queue is called as what? The process waiting queue. This queue is what? The process waiting queue. Okay. Now inside this process waiting queue, all the processes are listed. P1 process, P2 process, and a P3 process, for example. Now this for this P1 process, P2 process, there we need to provide some timestamps. Some resources must be allocated. Some timestamps must be provided. Okay. For that purpose, for allocating this memory, for allocating not memory, for allocating timestamps, no execution time. There we are going to use another component. This another component is what? Process scheduler. This another component is like what? There process scheduler. The process scheduler is able to follow number of scheduling algorithms, round robin, first come first serve, shortest job first, and so on. All right. Definitely, depending on the operating system, it may follow the underlying process scheduling mechanism. Right, sir. There is no guarantee then to use a particular mechanism, but depending on the operating system, they will follow that internal process scheduling mechanisms. Okay. Now here, what is going to be happen? Now here we are having three processes. What are the three processes here? First one is what there? P1 process. The second one is what there? P2 process. And the third one is what there? P3 process. Now process will start there. Before that, I'm giving some clarity for you. Observe carefully. To complete this T1 task, how much memory it will take there, how much unit of RAM, how much execution time it will take there. Say for example 10 units of time. To execute this T2 task also, how much time it will take there? 10 units of time. T3 for example 10 units of time. Okay. Now here what happened? Now our system was started. When our system is started here, then what happened there? First of all, in the queue, first one is what there? P1 process is coming there. Then for that P1 process, it will assign, say for example, 5 units of time. Meanwhile, then what happened there? When 5 minutes of time is assigned here, automatically T1 task is going to be executed by this P1 process up to 5 minutes of time. It's going on. It's going on. Just it is started. Then it will calculate 5 minutes of time is completed here. 5 minutes of time is going to be available. So remaining expected time is what there? 5 minutes of time here. But still some time is remaining there. Then what happened there? This P1 task will be pushed back to the process waiting queue. Meanwhile, now it is going on, not yet completed. This 5 minutes of time is not yet completed. Parallel to that, process scheduler will take a P2 process from the process waiting queue. P2 process from the process waiting queue, right? From this, for this it is able to assign 3 units of time, for example. 3 units of time in the sense just about to start. This 3 units of time it is going to start, but not yet started. Think of it. Now it calculate expected remaining time for it. 7 units of time is remaining for it, but still it is not complete, but just it is about to start. Still some time is remaining there. Then immediately P2 task will be pushed back to the process waiting queue. Right, sir. Next one. Now here P1 is under process, P2 is also under process. Now immediately P3 process will be taken out. For this P3 process, then scheduler will assign like what there 7 units of time, for example. 7 units time in the sense, now here just we can understand it, no? It will calculate it. 7 units of time in the sense, definitely some time is going to be remaining here, 3 units of time. Immediately it is started. Just a 3 units of time, it's going on. Observe carefully. Meanwhile, when P2 and P3, whenever they are in processing, and moreover, still some execution time is remaining there for P3 process. This P3 process will be pushed back to the process waiting queue. I think so. It is almost 7 units of time is assigned like this. All right, sir. After completion of this, what next one here? Observe carefully. Now, one time all the processor having resources, one time assignment is going on, one time they are executing. This one time assignment of the resources, execution time and memory, that overall, that is called what there, one cycle we completed. One cycle we completed. Next cycle now it is taking no. Again now next one P1 will be taken out. When P1 is taken out, now this time it has assigned like how much memory it will assign for this P1 process, no? 3 units of time. When it is assigned 3 units of time, now again remaining 2 units of time is remaining here. 2 units of time is remaining. Still some time is remaining here. This will be pushed back to the stack queue. Okay. Next one is still it is going on. Going on, just started but not completed. Meanwhile, P2 process is available. The P2 process will be taken outside. For this P2 process, execution time is remaining time is 7 units of time. Immediately, it may assign, for example, 5 minutes of time. I don't know exactly how much time will be assigned for the process here. It's depending on internal scheduling. Okay. Just awareness I'm telling there. Basic idea I'm giving there. Exactly the same figures are going on or not, we don't know. Okay. Now what happened here? For V2 process, 5 minutes of time is provided. Now it will calculate still 2 units of time is remaining. Still some execution time is remaining here. It will be pushed back to the waiting queue. Completed. Next one is what there P3. For P3 process, remaining 3 units of time will be assigned. Overall 3 units of time will be assigned. Now it will calculate it. 3 units of time is assigned here. The remaining execution of time is what there 0 units of time. So it will start immediately. Of course, now here also it was started. I think I forgot to draw this one. It was started there in the middle. Now here no execution time is remaining for this, so it will be popped out from the queue. No, it is not going to be available. Right, sir? When this execution is completed, for example, at any particular point of time, it is going to be completed. When it is completed, it will be removed from the memory. This process is also be destroyed. Next one is what? Next one here, P1 process is available. For this P1 process, scheduler may assign 2 units of time. When it assigns 2 units of time, the remaining execution time calculation is like what there? 0 units of time. Now the remaining total part will be completed. Remaining part will be completed. Okay. When it is completed, it's going on there. Immediately it will be popped out from the stack, from the queue. Only one thing is remaining here. That is what the P2. For the total required time, remaining time total will be assigned to what there? To this particular one. Now here. Now what happened here? Now here also how much time is remaining there? 0 units of time is remaining. Now here we are getting it. Now this is the total program execution is completed here. It is also be completed. But observe carefully. This also be completed. This process also be completed. Alright. Now the next one is what there? This also be completed. This process also be completed. Alright, sir. When the waiting queue is an empty, by that we can understand it clearly. The total, all the tasks are completed, all the processes are executed. Now tell me guys, from this particular flow of execution, what do you understand now? Tell me. How many tasks are executing? How many tasks are executed at a time now? Tell me. How many tasks are executed at a time? It allows more than one process to complete the application. Now tell me. It follows. It follows what type of execution? Sequential execution or parallel execution? It follows what type of execution? Parallel execution. When it follows parallel execution, what about the execution time? Is that execution time will be reduced or increased? Execution time will be reduced or increased? It reduces the application execution time. Nice. When it reduces the application execution time, what about the performance? Performance is what there? It increases the performance or reduces the performance? It improves the application performance. Moreover, now tell me a small calculation. Total memory 100 units, no? Utilized memory is how much, no? How much memory is utilized here? Overall, 30 units of memory utilized. 30 units of memory is utilized. Means that memory is utilized effectively or not? Memory utilization is effective or not when compared with a single process mechanism? Understand my point here? Now here it will be like what the 30 units of memory. Memory utilization is effective or not? Right. It utilizes the system memory effectively. It utilizes the system memory effectively. Okay. Right, sir. These are the points here we are understanding clearly. Single process mechanism. Okay. Before that, let me copy this diagram here. It is already available with us. Right. Now tell me, guys. All of you now tell me which one is better. Which one is better in our application development? Is that single process mechanism or multi-process mechanism? Which one is required in our applications? Single process mechanism or multi-process mechanism? Definitely, multi-process mechanism is suggestible. Multi-process mechanism is suggestible. Right, sir. The same process, same analysis we are going to apply in the future for threads also. Same thing we are going to apply in the future for what there? For threads. Observe carefully. Right, sir. Now the point is what there? In the above multi-process mechanism, above multitasking, controlling is switched from one process context to the another process context or not? In above multitasking, controlling is switched from one process context to another process context or not? It is called context switching. It is called as what there? Context switching. Okay. It is called as what there? Context switching. Context switching. Again, I'm telling to you, there are two types of context switchings. Lightweight context switching and second one is what there? Heavyweight context switching. Lightweight context switching and second one is what there? Heavyweight context switching. Alright, to understand it clearly, what is this lightweight context switching? What is heavyweight context switching? What is lightweight context switching and what is heavyweight context switching? Right, very simple. First of all, let me talk about heavyweight context switching. Heavyweight context switching. If the context switching is going on in between heavyweight components, if the context was switching, if the context switching is going on in between two heavyweight components, then that context switching is called heavyweight context switching. Now observe carefully. I'm going to give an example. Context switching between two processes. Context switching between two processes is called heavyweight context switching. Context switching between two processes is called heavyweight context switching. Why? Because process is heavyweight. Then what about this lightweight context switching? The same definitions here we can understand, but small changes are available. If the context switching is going on in between two lightweight components, then the context switching is called lightweight context switching. Context switching between two threads. Context switching between two threads is called lightweight context switching. Lightweight context switching. Okay. Context switching between two lightweight components is called as what there? Two lightweight components. That means that is what the two threads is what there lightweight context switching. That's it. Right. Now this is exactly the point here we can identify. Okay. Now immediately we have a question. What about this question now? What is the difference between process and thread? What is the difference between process and threads? All of you observe carefully. Process is a heavyweight. It will take more execution time and more memory. It will reduce the application performance. Process is heavyweight. It will take more execution time and more memory. It will reduce the application performance. That's it. Thread is lightweight. Thread is lightweight. It will take less execution time and less memory. It will improve the application execution time. It will improve the application performance. That's the meaning of like what the thread. Process and thread both are different. Thread is derived from process only, but the point is what there. Process is heavyweight, whereas thread is what there lightweight. Right, sir. Now again here in threading, we are able to see the points now. There are two thread models. There are two thread models. What are the two thread models here? First one is single thread model. Second one is multi-thread model. Single thread model, and second one is what then? Multi-thread model. Alright, single thread model is almost the same as the single process mechanism. Multi-thread model is almost the same as the multi-process mechanism. Single thread model, at the same time I'll give parallelly multi-thread model. You have to understand this both. Single thread model and multi-thread model. What is single thread model and what is multi-thread model? It allows only one thread to execute the complete application. But about this multi-thread model, it allows more than one thread to execute the complete application. Okay. It allows only one thread to execute the complete application. It allows more than one thread to execute the complete application. Next one is after that. Another point here I'm telling there. It follows sequential execution. It follows parallel execution. It follows sequential execution. It follows parallel execution. Okay. It follows sequential execution. It follows parallel execution. Next one is what then? It increases application execution time. It reduces application execution time. After this, it reduces the application performance. It improves the application performance. That's it. This is the total point here, what I am discussing with you clearly. Alright, two thread models here we are completed there. Now I'm talking about Java. Java is what? Java is what? Java is a single threaded programming language or multi-threaded programming language. Java is what? Is a multi-threaded programming language or single-threaded programming language. Alright, Java is a multi-threaded programming language. Java is multi-threaded programming language. Why? Because Java provides a very good environment to create and execute more than one thread at a time. More than one thread at a time in order to perform multiple tasks at a time. So Java is very good at what there that means Java is multi-threaded programming language. Not more than that. Everybody understand this point clearly. Getting clarity, all of you know? Right. Now Java is multi-threaded programming language. How it is multi-threaded programming language? No, it provides very good environment. It provides very good environment to create and execute more than one thread at a time. To create and execute more than one thread at a time. That's it. Now this is exactly the meaning of like what there multi-threaded programming language. That's now it is completed. Understand it? Then after this, after completion of this, the next point here. But how we are going to create threads inside the Java? How it is possible to create threads? Thread creation. To create and execute threads, Java has provided the following predefined library. As part of java.lang package. What predefined library here we are able to get there? One is what the runnable interface. Thread is a class. Between these two, the relationship is like what I'm telling to you, implements. This totally is come under lang package. This complete lang package is provided inside Java. Java.lang.runnable, Java.lang.thread. Okay, this is the predefined library what we are getting now. Completed. That's it. Next one is what is thread and in how many ways we are able to create threads? One of the important interview question. What is thread and in how many ways are we able to create threads? Already thread is a flow of execution to perform a particular task. There are two ways to create threads. First one is there are two ways to create threads as per the predefined library. As per the predefined library, which we provided in, which we have in Java, by extending thread class. Second one is by implementing runnable interface. By extending thread class, second one is what there by implementing runnable interface. Okay. Now we are going to understand both how we are going to provide this content here. Threads design. Here I am going to discuss with you. That's the design. First approach. Extending thread class. Extending thread class. How it is going to be happen, that we are going to understand that. Don't worry. Alright, so this part I will discuss with you on tomorrow. Tomorrow, maybe probably we are going to have the classes in both offline and as well as in online. There I will discuss about this first approach of creating threads clearly. Then after that second approach, their internal flow of executions. Then we are going to continue the content clearly. Right. Thank you guys. Thanks a lot. I'll meet you tomorrow. Just within a few minutes, I'll start advanced Java class. Just wait here. Wait here. Thank you. Yeah, same workshop link for advanced Java guys. Use the same workshop link for advanced Java.